So we're the Reef Institute. We're on a mission of coral conservation through education, research, and restoration. We're actually in Palm Beach County. So if you know that there's coral people in Palm Beach County, well, there is. So we're gonna actually get a pause here. And I like to start with everything that I do. Other people on days like this, it's kind of obvious. People understand recycling. They understand trees. Nobody really knows what coral is or why it matters. So I like to start with a little interaction. So you've been sitting and watching for a little bit, so we're gonna play a little game. So I need everybody, and I know several people just got snacks, so I'm just gonna ask you to like perch your snack for a moment and just kind of give this to me. All right, so what I need you to do is we're gonna do several of these, okay? We're gonna put up 10 fingers, and this stands for 100%. We're gonna play a guessing game on what you know about the ocean, what you know about coral, what you know about coral reefs, and why they matter. All right? So can I get everybody to do this for me? It's a good interactive game because for us introverts in the room, we can just like silently guess, but the extroverts feel like they're doing something active. So, all right, here we go. We're gonna start with some easy ones before we even get into coral. How much of the world's oxygen comes from the ocean? So remember, this is 100%, so how much of the world's oxygen do you think comes from the ocean? We talked about trees, the importance of trees, but 50 to 80% of the world's oxygen comes from the ocean. It comes from plankton, it comes from algae, so 50, and it depends on which scientist is wrestling over the statistic, but 50 to 80% of the world's oxygen comes from the ocean. Okay, we're gonna do this like 5 or 6 times, so just keep coming back to it. All right, so how much of the ocean has been explored? How much of the ocean has been explored? I like to do this one because a lot of people have heard this 5% statistic. 5% of the ocean floor has been mapped. 20% of the ocean has been explored, which is still a very small statistic, but Woods Hole has just created some technology that they estimate in the next 5 years, 95% of the ocean floor will be mapped. For the first time in history, about 6 years ago, the first explorer went to the deepest parts of the ocean. I tell you that to say that as much as we know about the ocean, we know nothing about the ocean. It is a huge contributor to our weather. It's a huge contributor, as we just saw all the hurricanes churning out in the ocean, it's a huge contributor to our oxygen source, and yet we know so little about it. Okay, we're gonna get into some coral facts now, okay? How much of the world's oceans, in the entire world, do coral reefs take up? How much of the world's oceans do coral reefs take up? Less than 1%. So we talk about them a lot here in Florida. Florida's coral reefs actually run about 365 miles from dry Tortugas off the coast of the Keys all the way up to Port St. Lucie. So our reefs are really, really important to us. People don't even realize that there are reefs north of Fort Lauderdale, but our reefs are really important to us, even though they take up, we talk about them a lot, but they take up a really small space in the ocean. Okay, we're gonna do 2 more. They take up less than 1% of the ocean, but how much marine life directly relies on coral reefs? So there's like an indirect, but directly like living around coral reefs, how much do you think? Okay, so we would argue as the coral people that coral is the foundation of the ocean, and indirectly everything in the ocean comes back to a reef, but directly living around a reef, 25% of marine life lives around a reef directly. So that means they're relying on that reef. Billions of dollars of Florida's economy relies on our coral reef system. Billions of dollars. Okay, so here's my last statistic, and I like to call this the selfish statistic. Okay? Because all the other things are nice and gentle and wonderful, but we may or may not care. How much of the world's, so when we look at wave energy, so we just had 3 hurricanes churn through the ocean. Even though we were really lucky and they missed us, they did not miss us offshore. So how much of the world's wave energy is first absorbed by a coral reef? How much of the world's wave energy is first absorbed by a coral reef? 97%. So our first line of defense against erosion, against, if you saw last year after the hurricanes that came through, there were some pretty famous photos of Daytona Beach with hotels right on the beach with literally their foundations kind of coming out from underneath them. That doesn't even get into the fact that our beaches are built by the breakdown of coral reefs. But beaches, I call it the selfish statistic. So here's our last one, and I'm going to explain to you what's happening and why this matters in just a minute. But in Florida, how much of our coral reefs are left? They're dying. I think if I asked you what's happening to them, everybody goes, they're in trouble. How much of them are left? 2%. So if I had set you up and checked if you were listening, I would have said we should have 365 miles of reef. I will tell you this, if you look in verbiage and literature about Florida's coral reefs, you'll notice that we no longer really promote that we're the 3rd largest barrier reef in the world. And that's because we have 2% of our reefs left. So I have now inspired you with hope. And so what I'm going to talk to you about today is actually what's happening to them, what you can do to help, and what's really cool is that there are things that we can do together to fix this issue. All right, so I'm going to go kind of fast because I only have 30 minutes. I think Kent was afraid. He was like, your video is only 6 minutes long. I was like, oh, I can talk. So coral is an animal. So I'm going to give you some basics. Coral is an animal that relies on a symbiotic relationship with an algae for its existence. This is important to understand because, and I should put it this way too. Coral falls into basically 2 categories, what we call reef building or stony corals, and then what we call our soft corals. So our soft corals are those big sea fans or the sea whips that you see pictures of. They only have enough skeletal structure to kind of help keep them upright. Those stony corals or those reef building corals are the ones that when we talk about the wave energy being absorbed, that's what matters. In Florida, we only have about 43 to 45 different species of reef building corals. This is also important to understand because in the Pacific Ocean, there are hundreds of different species of reef building corals. How many of you before today thought that the Great Barrier Reef was in worse shape than Florida's reefs? Out of curiosity. Okay, we had one honest person. So most people say, oh, but what about the Great Barrier Reef? Great Barrier Reef, as bad as things are, there still has 40 to 50% of its reef coverage. We have 2% of our reef coverage. So here's another, I'm going to kind of give you some coral facts so then we can kind of go through what's happening. So we care about those reef building species. We don't have a lot of different reef building species. And then the other thing to understand, how many have people seen in the news about coral bleaching this summer? Okay, so that's made the news pretty extensively. And so here's what happens when coral bleaches. Coral lives in this symbiotic relationship with this algae. This type of algae is called zooxanthellae. It only lives in coral, giant clams, and some nudibranchs that eat giant clams and end up absorbing the zooxanthellae. It gives coral its color, it gives it most of its nutrients, and it's an oxygen producer. It's photosynthetic. So when a coral bleaching event happens, here's what happens. That coral begins to, that algae begins to overproduce oxygen, the animal itself gets upset, and just like any of us, if we had something, we were choking on it, it chooses to expel the algae. It now begins to starve to death. It's called bleaching because the animal itself is clear, at this point in time, and you can see through to the skeleton, so it looks white. It looks like it's bleaching. At this point in time, the animal is actually still alive. And if it can survive what we call a bleaching event, it actually can, with really cool science has proven that it can regain more resilient zooxanthellae that can protect itself against, and help it to adapt against future bleaching events. However, when things like this summer happen, which is our ocean temperatures got much hotter, much earlier. July was the hottest July in global history. We had the hottest surface ocean temperatures in history in the Florida Keys. They were as high as 105 degrees some days. That shouldn't have happened till late August, September. What should happen with us is our ocean temperatures get really hot mid-August, the hurricanes come through, churn everything up, cool everything down, and then even if they've begun to pale or bleach, they can regain that zooxanthellae. What happened this summer is it happened too quick to corals, and they are the divas of the ocean. They're not fast adapters. If any of you are a personality type that's like, I don't like change, don't move my cheese, then coral is your spirit animal. And so that's kind of what happened to them this summer. So we have disease that's been taking them out. What do you think are some of the other things that have been taking out? I mean, we have this bleaching event, but what are some of the things that you think are causing these ocean temperatures to warm, that are causing these issues? What are some of the things you've heard about why coral is dying? Pollution?
I was going to say more like salt from the glaciers melting, causing the ocean events.
Yeah, pollution, it's a saltier place. What else?
Maybe that's sargassum stuff?
Okay, like just choking, things like that. Human impact. That's why it's really important to do things like recycle. I will give a little plug. If you ever see a garment that says it contains Reef fabric, there's a lot of clothing companies that are using this now. I think it's like every t-shirt has 8 to 10 recycled water bottles in the fabric. So it's not a company, it's a fabric, it's a thread that they're making. And then Reef Fabrics sells this thread to multiple companies. So if you ever see something that contains Reef fabric, that's like you're wearing recycled water bottles. So just a little plug there, as we were taught as the solid waste authority was before. Okay, so all of those things are the usual suspects. Here's what happened in 2014. In 2014, a disease called stony coral tissue loss disease was first detected off the coast of Miami in Virginia Key. Here's why this disease is important. It is not the first disease corals have ever gotten. It will not be the last disease. Here's why it's important. It affects over half of our reef building species. Number one, other diseases kind of target 1 or 2 species. This is over half of them. Second of all, so when you look at a colony of coral, it has all these little polka dots in it. You saw like a little picture before, if I had more time, I would go back, like little polka dots in it, you'll see it. Those are all individual animals living together as a colony. It's the same family of animals as jellyfish and anemones. So you can think of it as each polyp is a jellyfish flipped upside down with a base that doesn't move. And so what happens is that they're growing together. This disease enters into one single animal, and the entire colony that could be somewhere between 50 to several hundred years old is completely devastated and decimated in between 2 days and no more than 2 months. So it's a very fast-moving disease. It has a super high mortality rate, and the last piece about this disease and why it's important is the only thing that we've really been able to learn about it in almost 10 years. It will celebrate its 10th anniversary this year, is that it's waterborne. That's the only thing we know 100% about it. There's a lot of theories about the pathogen, but we only know that it's waterborne. So at the Reef Institute, we take what we call a rescue to reef approach to deal with these bleaching events and this disease event. So the first thing that we do is we work in coral rescue. We are the only coral rescue facility in Palm Beach County, and we're the only ones doing the number of things that we do. So we work with 25 different species of coral. We work with corals that have survived the disease. And these corals that you see right here actually came from Palm Beach County. This is pillar coral. We work with 4 species of coral that are considered threatened animals in the Endangered Species Act. This is a pillar coral. We're one of 3 organizations that's given the privilege of holding this. So the first idea you can think about it is rescue from disease. The second is we were really, really honored this summer to be one of 2 organizations allowed to take corals in from this bleaching event. We currently have 200 corals that have survived the bleaching event that will now live in our facility full-time, and I'll kind of explain how that will work. And the plan is every 6 weeks to bring in another set of corals. So by the time we're done, we'll have 1,000 corals. So we rescue from both bleaching and disease. Then the second thing is kind of this idea of reproduction. So corals can reproduce asexually and sexually. Because so when you look at this coral, each little ridge is a different animal. You can see its mouths are actually here in the cusp. These are all different animals living together. So what's really cool about it being a colonial animal is you can actually cut it in half, and it will continue to grow. It will create clones. So those bleaching corals that you saw, they will have one piece of their genetics will always live with us. It's called a mother colony. And then as it grows, the little pieces will be cut off and put back out into the ocean. So our corals rescue from the disease when they get big enough will move like that, but that's kind of the first step. The second step is in sexual reproduction. Next week, my staff and I will be split in 2 different locations across Florida to help with land-based reproduction. This idea of using technology, those are corals that we produce at our facility, but this idea of being able to use technology to mimic the ocean is brand new. And so I want to make it clear, as we're talking about climate change today, that the first corals that came in from the bleaching event, those were a direct response to a climate change issue. It was a direct response to ocean temperatures rising. The disease is an indirect issue with climate change. We've created, us humans have made lots of choices that create, we would all love to point to one thing. Oh, if we were recycling more. Oh, if we didn't wear the wrong sunscreen. Oh, if we were all vegan. Oh, if we all drove electric cars. But the reality is, it's all of the choices together that have created a situation in the ocean that makes it a hot spot for disease to spread. And so that's kind of what happened in that rescue. And that's why the rescue piece is always important. Is really, really important, but the idea of restoration is equally as important. Because the cool thing about coral is you can bring it to land, you can save it, you can reproduce it easily, and then you can put you can put it back out in the ocean. I mean, you can keep. You're going to ask, well, isn't the situation in the ocean so bad that it doesn't matter? I would argue the opposite. I would argue that it 100% matters because we can keep making new attempts, we can keep crossbreeding corals, and we can keep trying to create a more resilient coral to be able to handle kind of what we throw at it. The only time coral moves in its entire life is in the first 72 hours of life. So what looks like little pieces of dandruff at the surface of the water right there are actually baby corals. Coral is a really crazy, awesome animal because even though it has, and this is what it looks like under a skeleton, under a microscope, within about 72 hours. So what's really cool is that it has no brain, it has enough neurons to be able to have stinging cells and protect itself, and yet it's been proven that it both smells and listens for a healthy spot on the reef to be able to land. So what we do on land is create kind of mimic situations to make it land. And then we're going to grow it up, and then what we're going to do is put it back out in the ocean. So what you see here is these are all babies that have been it's called settled, have been settled in our facility. It grows to that, then it goes to that, and then they're going to go back out in the ocean. And us at the Reef Institute, our corals go back into Palm Beach County. So other facilities are putting new corals back in the Keys or are part of other rescue efforts. Ours are in Palm Beach County. We were the first organization, along with Palm Beach County Environmental Resource Management. They partnered with us. It's our corals. They helped us put them in the ocean to put them in Palm Beach County as a pilot study. So here's why. Coral reefs in Broward South, they're pretty much in 15 to 30 feet of water. In Palm Beach County, do I have any divers in the room? Okay, the divers in the room, our natural reefs are 30 to 90 feet with a ripping current. So nobody's wanted to take this on before. And so we were the first ones to take it on. So you can see they were placed at the bottom. This is a site in Lake Worth that we did not pick. The state of Florida picked it as a pilot. The triggerfish were obnoxious and bit everyone, so that's why the trigger got kind of highlighted there. And then you can see we prep the site, we lay out transects, we use epoxy, and these are still doing great. We check on them every month, they're growing. The only issues have been sedimentation. And you can see she's even struggling with the current to get them down. And it's funny because I was at a state meeting where they said, well, we feel like we understand restoration in Florida. And I asked the question, then why were we the first ones to do it in Palm Beach County? And they said, because nobody's wanted to take it on because the current's obnoxious and it's difficult to dive up there. Since we don't know everything about being able to outplant in Palm Beach County. So the next site, our next set, we were supposed to put out another set in the same site in July, then our ocean temperatures went crazy, and then, so now they will go out in October in the same site, and then Palm Beach County is actually working with the state of Florida to pick additional sites in Palm Beach County to be able to put corals out for restoration. Right now, it's considered a pilot, because when you're the only one who's done it, they have to call it a pilot. But we would argue that it's as they continue to grow, you can see there's not a lot there. That's restoration. So those corals are about 2 years old, and they will take about probably another 5 to 10 years to become reproducible, but that's the goal. We're putting out this genetic diversity so that they will be able to reproduce and they will be able to solve the reef. So the next thing I want to talk about really, really quickly is kind of this idea of innovation. And because I only have 5 more minutes, I'm going to go fast into the last thing I want to talk about, since we're talking about kind of this idea of climate and art. And that's what it looked like last month, just so you know. We call them the SpongeBob clouds, because they kind of look like SpongeBob clouds. All right, so I am going to go a little bit ahead in here for the sake of time. We are also using shipping containers to make a spawning lab. We work across the Caribbean. You're like, yes, yes, yes. Okay, so here's what I want to talk about in the last kind of portion that has to do with Delray Beach specifically. So we partnered with Michael Singer Studios. We're actually on our 4th year of our partnership with them to develop something that we affectionately call the Marine Living Structures Initiative. It is an ecologically engineered reef. It's made of 70% recycled materials. So it's actually recycled glass, recycled oyster shell, and recycled Portland cement. If you're not aware, Portland cement and the production of Portland cement causes one of the largest carbon footprints in the world. This reduces the carbon footprint in the way that it's produced by 50% while remaining strong, while keeping the same PSI as cement. It's a modular unit that can be built either small to kind of connect disconnected reefs, or this one is in Sugar Sands, which is up in West Palm. I always refer to it as the other side of Blue Heron, like off the boat ramp, and you can see we were able to outplant some corals on there, and it's doing phenomenal. And then the very, very final thing that I want to talk about in my last 2 minutes is Peanut Island. Who here has ever been to Peanut Island? Okay. Who here knew that it has better biodiversity than the Florida Keys and 23 different reef-building species of coral? No, we affectionately refer to it as the cesspool of tourism. Because of the number of people that are there and the way that it's treated. When we talk about adaptable corals in climate change, that's an example of corals being given the opportunity to be those slow adapters, to adapt to really difficult situations. So the final thing that we do is we have a large education program, but I will be around to be able to answer questions. Some of you already took them. We have actually referred to it as our fish card. It's a fish ID card because we want when people come out to Peanut Island to really understand the things that they can see there. I also have a couple of stickers there if you want to stick it on a reusable water bottle, and some business cards that have our QR code on the back of it. But I'm happy to stay around and answer questions at the end. But that's us, and that's what we do, and that's what we're trying to accomplish.